Thank you, everyone. We have the cast of thousands here, and I'm delighted to have everyone able to join us. My name is David Lassner from the University of Hawaii, and this session is Policy and Governance, What Actually Matters. Our guests are Kiyoshi Mori, who is the Director General of International Affairs of the Ministry of Internal Affairs and Communications, or MIC, in Japan. My friend Jun Murai, Dean Professor, sometimes called Father of the Internet in Japan, at Keio University in Japan. Tricia Paoletta, who is currently a partner at Harris, Wiltshire, and Grannis in Washington, D.C. Robert Pepper, no stranger to PTC also, who's the VP for Global Technology Policy at Cisco, and a newcomer to PTC. Please welcome Xiao Zhang, who is the Director of Information Resources Division in the Bureau of Information Development, Cyberspace Administration of China. And we're delighted to have all of our guests here today. So for this session, we have no prepared presentations. We have a set of questions that we thought would draw out perspectives, particularly from the diversity of countries and experiences of our panelists. So let me really just jump right in with the first question. And for each of these, I'll try to get 2 or 3 panelists to comment and see if we can share different viewpoints on them. So generally speaking, how do the US, Japan, and China promote the use of ICTs and coordinate, deregulate, or control the possible outcomes brought by the use of ICTs? And maybe I'll ask, please, Mr. Mori.
Thank you very much. I used to be the energy negotiator in the government. What the difference between ICT and energy is that in the ICT, policy coordination, policy subjects have been changing faster and more drastically than that of energy. With the increasing change of technologies and business practices, then policy making in the ICT should be flexible and at the same time tolerant to the changing of policy subjects. Therefore, what is kept in mind for the policymakers is to, I think, seek for simplicity. Back to Russell-san's questions, regulations. We are trying to make the best effort under the scheme of economic special zones under the Abenomics. The policy framework itself is very simple, but hard to be executed. But we have a strong leadership right now, so we would like to do it successfully. Thank you.
Thank you. And maybe Xiao Zhang?
Thank you. Good morning. Good noon. And I think we have something very similar, like to promote infrastructure and policies and to help SMEs and some deregulations. But we all have something very different because it depends on different conditions in each country. And in China, such as we have some different backgrounds, like the first one is we have a huge market. We have 1.3 billion people. That means the consumption is strong. And the second is it's an agricultural country. We are in the urbanization process. There will be a lot of new towns, new cities, so smart cities, so it's important in China. And there are also, so what it means to us is that there will be a lot of potential possibilities. You must be more tolerant. You don't know what happened tomorrow, but you should let the vertical supervision to something more participatory. And it's from bottom to up and together with from the top to the bottom, participatory policy making. So much more involved and be tolerant.
Thank you. And maybe Tricia, perspective from
Sure, I'd be delighted. Thank you, David.
The Beltway.
Yeah, the remarks remind me of back in the days when we were at the FCC, Pepper and I, and after Clinton was elected, and talking about promoting the global information infrastructure and national information infrastructure, and so it is important to have a national vision. I'd say that there's also some key participatory principles that are critical, and they are constant, whether you're promoting ICT or anything else, and that is a participatory government process, an open discussion. In the United States, we have a requirement under our laws that proposed rules must be published, that there must be a comment on the record, and I think regardless of what you're trying to promote, those are still great principles, and clearly they've had an effect, as we've seen over the last couple decades.
Thank you. Next, something that I know we had a session on yesterday, but I'm told the room was not as full as this one. We want to ask a little bit about the transition of the stewardship of IANA from the US Department of Commerce. And maybe I'll start with Jun Murai.
Okay. Well, IANA transition actually on the internet operation space, then it was kind of defined like a long time ago, like 15 years ago. And then when we started the, in a year a little bit before the year 2000, then we started the ICANN, and then well, it was long before that. I mean, it's a historical contract, is a sources of a contract of the U.S. Department of Commerce and the IANA things, and then it's a transition things was when the ICANN started. Then we planned anyway for a long time, and then finally it's time is come, and then it's a moving. But the one thing I'd like to mention about the transition discussion these days is that the IANA is a name and the protocol numbers and the address space, right? That's a law, and then allocation of it, and with a kind of that has to be stamped and signed by a DOC. So that's a fact, and then only the signature part, but very importantly, the people cares about the names, like domain names, and a lot of policy discussion and the business discussion as well for the domain name, but which is different from the protocol definition, number definition, and the parameter definition, and the address space, allocation things, which is the two things, address and the numbers. I mean, other protocols are very much engineer oriented, and then it's kind of easy for from a political discussion things, but the names. Since it's involved with intellectual property issue, and this is my name and the global space, so a lot of discussion is going to be necessary. So those are the reality of IANA functions. But many questions I asked IANA, director, CTO of ICANN yesterday on the panel that how much percentage, how much ratio of questions is unrelated to, questions about IANA is unrelated to IANA functions, and he said 99%. So it's a kind of all the policy questions of internet in general. The filtering and the fragmentation and the other things, is going to be interpreted as an IANA transition discussion. So which is wrong. Which is not the reality. So we have to be very careful. But the operation of the global internet is a really important thing to be sustainable, continuable, and growing. So it's really important. Every stakeholder is going to work on keeping this function properly working.
And I know that this is something Cisco cares about. Robert, you want to add anything on this?
Yeah, in fact, picking up on what Professor Murai just said, that what's really important about this process is it absolutely embodies the notion of a multi-stakeholder process. Right? This is not a government-driven process. It's all the stakeholders have an opportunity, and they are participating in the different communities. So it's the technical community, it's the business community, it's civil society, it's the academic community, and also there's a role for government as part of that process, right? Government clearly is one of the stakeholders, but the multi-stakeholder process, has proven itself over 30 years as a very bottoms-up process, very successful. The internet works, right? And in fact, ICANN works. The, IANA, working with the Internet Engineering Task Force, the Internet Architecture Board, the IAB, as part of this total ecosystem, it's working. And, I also agree that a lot of the public debate, most of the public debate, I guess 99% of the focus are on things about names, right? And some of the names issues have nothing to do with really running the internet, right? Some of those are often to trade issues like, .wine and the controversy around that. But the community has and will be resolving those questions. That's not really about what the IANA transition is about.
Thank you. PTC is, please.
One more sentence. I think that will not be one size fits all policy. So we have to be keen to the demands.
Yeah. PTC is one of the places that brings together all different sectors of ICT and telecommunications. And we have a World Radio Communications Conference coming up. And one of the issues that we'll face is the increasing demand for capacity for mobile broadband spectrum, and which challenges in some cases, in particular satellite communicators, operators, and others. Tricia, you want to comment on what you think?
Yeah, certainly. Thank you, David. Yeah, so the International Telecommunications Union is hosting a World Radio Communications Conference later this year in November. The agendas, though, for what we call WARC, or WRC, are set at the prior WARC. So the agenda for this year's WARC in November was set at November 2012, basically. So the number one agenda item, both literally and figuratively, is 1.1, and that calls for reviewing all spectrum bands for more mobile terrestrial spectrum. And the industry and government and satellite, everybody's been engaged in years now of discussion and debate and proposals, and again, a very participatory bottom-up process. In each country, I assume there's a comparable process as in the United States, where there's a domestic process, and then you go to your regional prep processes, and there's, of course, APT hosts one for the Asia region. CTEL is the Americas region. But you negotiate spectrum bands. So certainly there are proposals from the terrestrial mobile industry for spectrum that satellite probably feels very protective of, and I'm speaking about the C-band. And that's 3,400 to 4,200 megahertz, and we can hear, I think a number of panels have addressed that. But the mobile industry, of course, is voracious in its need for more spectrum. We've all seen the charts that Cisco and others have put together in terms of mobile demand doubling every year. I mean, obviously the numbers are staggering. However, WARC has about 20 agenda items. The other 19 are pretty much satellite items. So satellite is well positioned to fight for its spectrum. But these are still very open questions. In the U.S. itself, we do not have a proposal as the U.S. Government, which is both industry and government working it out for C-band. So that's going to be an interesting discussion as the months wind down towards WARC. We have a few other bands that are being promoted in 5 gigahertz. The U.S. has a future agenda item they've requested for more spectrum in 5 gigahertz, which would be perfect for, of course, 802.11 AC, which needs more bandwidth, 80 megahertz channels paired for 160. So we're having a discussion, but yes, it's not over. Stay tuned.
Thanks.
One of the important things about this, though, is that I agree with everything that Patricia said, but it's also then what happens after the World Radio Conference. And it then is about member states implementing. And by the way, spectrum is something that this is a sort of government function because of the way spectrum management works. If we go back to the World Radio Conference in 2007, that was a major decision that was made that was really migrating what was then called 700 megahertz band, it was actually 700 to 862, the old analog TV bands in UHF, migrating that for mobile broadband because of this incredible demand for mobile broadband and the foresight at that time. Not every country has followed that. The US turned off its analog television in 2009, right? And it had an auction in 2008 based on that, and as a result had the first continent-wide LTE 4G network. There are still countries lagging on the transition from analog television to digital television. They're still lagging on migrating the 700, 800 megahertz band from television to mobile broadband. It's now 8 years later. So the WRC makes some really difficult decisions. It works. It's one of the places where we build consensus globally, but it's up to the member states, each country, to implement. And that is frankly where we don't see the uniform application and the adherence to the decisions coming out of WRC. And countries that don't do that fall behind.
Only one.
Please, Mr. Murray.
Directly for Davidson's question, the keyword is a technological review on the spectrum sharing. And we think we can get a good discussion in the needed spectrum, and I think we can make a consensus in the next coming WRC'15.
Thank you.
Agree.
Next question is, what influence does e-commerce bring to the development of both economies and societies? And from a broader perspective, what are the policies that can foster smart cities with e-government, e-education, e-health, and more? Maybe first, Xiao.
Well, e-commerce was so hot now, especially in China. And I think last year, the most exciting thing in China is Alibaba, its success in NASDAQ. Everybody knows Ma Yun. And what struck me is it's not promoted by the government. It is by it's e-commerce. And what brings us, I think it's the first is we see the potential of the new economy. I have not noticed this several years ago in China. I was in Washington, D.C. in 2007, and there was seldom e-commerce in China. Only after several years, it got so much success because China is a huge market. So we see the potential of the new economy, and it's green, it's energy saving, it improves efficiency. So what it brings to society, I think a lot of it has very contributed to the employment. Around 10 million people are on the platform, and they sell things. And I think so a lot of them are very poor people, are rural people, and are disabled people. So it helps us. It's very, very helpful to society.
Thank you. Jun?
Okay, yeah, one of the interesting change on the ICT policy in Japan and probably in the other part of the world as well is, we've been, in Japan we started the kind of Prime Minister's ICT policy discussion from year 2000, and then when that time then related the ministries, right, and the ministers and the Prime Minister working together. So the Minister of the economies and the telecommunications related things, and then they're working together for the creating the infrastructure of the internet and other things across the nation, and also concerning the the responsibility for the global internet development. We changed the policy at all in 2013. Okay, so I kind of involved on the drafting it, but now it's not kind of certain related ministries, but all of them. So it's a cabinet-based decision, and then meaning that every single segment of the industries and the functions of the government should be involved on ICT development and the deployment in the country, right? Which is, in the education, agriculture, medical, and those are the different ministries, and kind of creating the silos in the functions of the government. But now the ICT should connect, and then any decision making is committed by all the ministries, meaning that every single industries. So this is a very important thing. I said that before internet and after internet. Now we are living on the after internet era, and so that anything, any industry, any business can be benefited from the internet and the digital communication infrastructure. Therefore, it's important that all the education and knowledge sharing and understanding of the future by all of the segments to understand correctly about what is the value of the digital communication, what is the value of the global internet for any kind of activities and the industries and the businesses.
I'm going to keep moving, and I see Robert's hand moving, but I'll punt this one to him. So part of this is smart homes, smart buildings, kind of smart everything. What kind of policies can and should facilitate, and I'll use the term, the Internet of Things, even though I know it's not your favorite term, Robert?
Well, no, I love Internet of Things, but we also use Internet of Everything.
Right.
And one of the reasons we do that is look, things, the devices, whether it's the machine-to-machine device, the sensors and so on, they're just things. They're not particularly interesting, right? Then they begin to generate data, make them a little more interesting, but data by itself is actually, not very interesting. And Michael Lynch earlier this morning talked about that, and I agreed with sort of everything that he said about that importance. It actually becomes much more interesting, though, when the data become actionable. When you provide the analysis, the analytics, and it moves information to knowledge, or it moves data to information, information to knowledge, and then the knowledge to insight or actionable data. And that is what we think of and what we call the Internet of Everything. We've done a study that I think many of you have seen that we released last year that looked at what we call the value at stake, the economic value at stake over a 10-year period, 2013 to 2022, if in fact the world converted to this Internet of Everything approach and architecture. And the economic impact, this value at stake, we estimated at globally, 19 trillion, that's with a T, $19 trillion. 14.4 trillion on the private sector side and $4.6 trillion impact value at stake on the public sector side. So we think that the impact of this, frankly, is going to be even greater than the economic impact of the internet to date. And we're beginning to see this across all kinds of applications, whether it's in eGov or across all the verticals that you talked about. The industrial applications. Earlier, talked about aircraft, engines, and so on. Some very concrete examples which we can talk about. So the question then is, what are the policies? And earlier it's not this year. Last year, I publish with a colleague. We usually have a chapter every year in the World Economic Forum's Global Information Technology Report. And in this year's report, we looked at policies for IOE, Internet of Everything, and big data. And we came up with a framework to think about that. There are some issues that are technology issues, and some that are policy issues. And then in the Venn diagram, there's the intersection. So, on the pure technology side, we have things like reliability, scaling, electric power, and so on. But in the policy, that also includes things like standards, interoperability, security, privacy, spectrum. Those are all policy and technology. And then on the pure policy side, there are questions about data localization. Data localization will kill the Internet of Everything. It'll kill cloud computing. Access to data, open data, legacy regulatory models designed for a completely different age, and even intellectual property rights. Who owns the data? What can you do with it? All of those are issues that are extremely important that have to be addressed in order to get to the point of the benefits of the Internet of Everything. Whether at this, again, public sector, what you asked about smart cities. 30% of congestion, traffic congestion in a city are people driving around looking for parking places, right? There are cities, whether it's Barcelona or in Spain or Nice or Chicago, cities around the world that are beginning to use an Internet of Things, Internet of Everything, technologies and architectures to point people to parking spaces. And by the way, they can reserve them in some cases and pay a premium for them. So number one, it reduces congestion. It reduces carbon, so it's sustainable. It lowers the costs on the city, and it increases revenue from parking, right?
Thanks.
So it's a win-win-win-win-win, right? So those are the kinds of things that we see, but you need the right policies to enable that.
Can I add on here?
Sure.
And in the United States, the regulator, the Federal Communications Commission, has begun a notice of inquiry to ask the industry about developments in 5G, which is the next mobile standard that would be helpful in supporting a lot of the Internet of Everything applications. And they're looking specifically at spectrum above 25 gigahertz, what some would call the millimeter wave spectrum. So it's those kind of forward-leaning policies that are critical to support any application, including smart cities, because we need more spectrum for that. And of course, the industry doesn't mean to imply that all the Internet of Everything, Internet of Things activities, the apps, would all be in upper band spectrum. The mobile, terrestrial, broadband industry certainly feels they continue to need access to spectrum below 6 gigahertz or 6 gigahertz and below, but also looking at spectrum at the higher bands and in what we call a HETNet, a heterogeneous networking architecture. But a lot of work will have to be done by the industry, and it's already underway in terms of new network architectures and new technologies, particularly on the radio side. And antenna will need massive MIMO, multiple input, multiple output. We'll need a lot of discussion to move the mobile networks into a place where they can support a much more dense environment and aggregate those different bands. That's going to be much more technically difficult. But the work is underway at the ITU and the Working Party 5D Working Party on 5G, which again is not synonymous with the Internet of Things, but certainly they're related. Right. And another fora too is industry standard settings bodies. But there's a lot of work that's going to have to happen. It's just not devices being made. The spectrum has to be there.
So a little blue skying. What other trends, technological or societal, do you think will shape the future? And of course, given our theme for this session, what kinds of policies will be required to address, for example, expectations around ubiquitous high-speed broadband? We've got to get that ultra-high definition TV to everyone, as well as to things, artificial intelligence. I know Jun has worked on self-driving automobiles. Where are the challenges? Maybe Xiao?
I think I lost one question. I like smart city. I think you don't know tomorrow. So for traditional industry and every of us, we are scared. We don't know. Maybe someday people can use big data to make policy, and I lost my job. So don't know the future. Like cloud computing, big data, we think they are very important now. But several years ago, we have not imagined this happen. So you don't know about the future. Just be open. But there are some things that we can do now, like to promote the infrastructure, enhance the ability, and we can deploy ICT as a general purpose technology and so on.
Yeah. The interesting things. I mean, a lot of research discussion things under even under the government, and they started to talk about artificial intelligence again. I thought, in the past 5 years, AI means agriculture informatics, but now it's artificial intelligence again, right? And so the reason why we can revisit the AI things and is cloud computing, and we have enough computing power, computing power, and then a lot of data to manipulate, and then what's going to be the use of those facilities, unlimited power of the computation, and unlimited amount of the data, and what we can do. So it's an artificial intelligence possibilities, kind of a revisiting from the kind of a computer creation to 10 years ago, 20 years ago to the real application of the AI type of thing, which includes the automatic driving and the other things. But my very, very interesting area is health, because it's globally requested. And in Japan especially, we have a very serious elderly societies, and then a lot of elderly people in the society, and what's going to be a productivities and the economy and insurance and other things, and also we're connecting with medical science, right? Which is also a very huge amount of the data and the computation things and the images. Okay, so now it's been kind of separated, right? Medical science application is a very, very kind of standalone area, and but connecting with the people's health on the society, then it's going to be the new opportunity. And then the good part about talking about the health and the medicine, it's kind of globally accepted. So we have to work together. So I think that's kind of a miracle challenging can be applying to the human being life, health, medical challenges for the future.
Thanks, Robert.
So I want to pick up what I think is a really important point, and that is the things we don't know, as you said. And we have to be flexible. And in fact, as a former regulator, one of the things I learned is that we had to be really humble because, forecasts are really hard, and you don't want to regulate in terms of theoretical problems. In fact, one of the things that the internet community, a phrase the internet community uses to talk about the incredible innovation that's come from the internet, right, is this phrase called permissionless innovation. The ability to innovate without first having to go ask, may I innovate, right? What we need to do is have the ability to innovate because, frankly, we don't know what's going to happen next. And on the medical side, let me give you one very concrete, I agree with June. I usually do. But very concrete example, right? And this is real. This is not science fiction. And this is an example of Internet of Everything. There's a company called Proteus, right? And they were trying to solve a very simple problem, but also complex. Older people, one of the biggest medical health problems for older people, they forget to take their medication. Right? And when they forget to take their medication, they can end up in an ambulance. They may have to go to hospital. It could be life-threatening. So they came up with this idea: what if we put a very, very small chip inside a pill, right? Which they did. It's called the Proteus pill. It's been approved by the Food and Drug Administration, which are very careful, stringent health regulators in the US for any healthcare product. And what this does is when you swallow the pill, right, and you digest it, it interacts with the digestive juices, and it gives off enough little energy, and it wakes the chip, it wakes it up. The chip, by the way, is the size of a grain of sand, right? And when it wakes up, it chirps, and it just says, very simple, it says one thing: hello, I'm here, right? And you wear a patch that's taped to your stomach, and it connects from inside your stomach to the patch. Then the patch has a little battery, and that connects to your smartphone or your Wi-Fi base station, and it connects back to whomever your health provider is. It could be a relative, it's somebody, a family member, it could be a doctor, it could be a nurse, and all they're waiting for is for the pill to say, I'm here. And if the pill doesn't call home, you can go to you can say, Grandma, did you take your pill? Please take your pill, right? And this is real, and it's saving lives, and it's saving a huge amount of money and trauma, right? And it's a great example of not just a thing, but we'd like to talk about people, process, data, and things. This is where it affects people's lives because it's changed the process, right? And it's information that's usable from a thing. Very simple, right? And there had to be this process in order to have somebody create it, have a great idea, but then have the ability to approve it and say, yeah, let's try this. And it's improved people's lives.
Yeah.
I just want to respond to Jim Ring. And you said, I think internet ICT development is very technology-driven. It's a supply. But for health in the future, it's the demand. So technology should very, in the future, responsible for people's basic need and individual need. That's the future.
Can I follow up on something? Sorry. He's telling me no, I can't.
Quick.
But real quick. Okay. Well, so the pill thing, that made me think my parents would not want any of the kids notified. They're very independent, very cranky. But obviously, if you take it, hopefully you've opted in.
Well,
but,
yeah,
but the focus on Internet of Everything in Washington, D.C. these days has been privacy and, you know, and the concern about misuse of that. So that will be one thing we will need to do to assure folks that their privacy interests will be protected. Okay, David, I'll be quiet
Thanks.
now.
Okay, let me move on. Last question. So we just talked about health, which is obviously one of the great global challenges we face. Another one, if I don't offend anyone's politics, is climate change, regardless of your belief about the source, whether you believe 97% of the credible scientists in the world, but leaving that aside, clearly climate change is a challenge we face this century. And in the US, the numbers I've seen suggest that ICTs are consuming more than 10% of the energy produced, and in many ways inefficiently. So to what extent have national, state governments and others embraced cloud computing in manners to reduce energy consumption or other energy efficient technologies? And what more can we do from a policy perspective to address this challenge? Please, Mr. Murray.
Thank you. I was in charge of COP3 of climate change conferences in Kyoto in 1997, and at that time, our team created a top-runner regulation mechanism for energy conservation. From my experiences, there is much room for energy conservation in the ICT sector. For example, as David-san pointed out, in the cloud computing era, a data center will need much more energy, and on the contrary, sensor monitoring can be done with less energy than through the current methods. And in these points, we can do a lot of things to do, and Japanese companies have exercised to that. And in addition to that, simple infrastructure is very good for energy conservation. Japan is #1 in the infrastructure of optical fibers, FTTH or FTT premises, and this is also good for energy conservation. So Japanese companies can contribute to do energy conservation. Yes, thank you very much.
I think that, yes, ICTs are consuming energy, but if you take a look at the way ICTs can address energy consumption in other sectors of the economy, it is even a greater opportunity. You take a look at smart grid. You take a look at what's happening now with the deployment of IT and ICT technologies for managing electric consumption. Look at what cloud computing is doing by having devices like this with everything in the cloud that consumes much less energy than the old desktop computer. So you have to take a look at the net and the dramatic contribution that networks and ICT and compute is actually helping to reduce energy consumption while at the same time increasing benefits. But it is about the deployment and the use, and I would agree completely that we often in meetings like this tend to talk about the supply side, getting people connected, or the networks. But without the use of it on the demand side, we're not going to see the benefits. I like to talk about, we have technology development, technology deployment, and then it's the adoption, and then finally the use and the usage. Yeah. The economic, social benefits come from the use and adoption. The supply side is the necessary but not sufficient first step.
Yeah, also it's really important at the policy side, because it's reducing the energy because of the from a cloud computing point of view, it's optimizing the entire resources around the world, right? That can be possible. So it's a kind of if you see the global space now, you have them, and then sophisticated way of optimizing the use of the energy is going to be reducing the entire energy. So when each of the nations is a kind of creating the boundary by nation and the country by country, then it doesn't work properly. So it's really important that the policy people, political people, government people working together for, specifically thinking and looking for, challenging for this kind of very sophisticated way of optimizing the energy in a global manner.
And the Obama administration showed great leadership in the first term by having a cloud-first strategy where they tried to encourage and almost mandate every department to move to cloud to the extent possible. And that leadership has trickled down to the states, and many of the states are trying to do that as well.
So thank you. How about a good round of applause for our 5 panelists? Thank you very much.